So that is all that there is. Look at the action of the magnifier, double concave lens. One might remember how that works. Let me illustrate the drawing here for a minute. Just look at this from the top. Here is a lens. Here, right there is a dot, which is the object. The rays from the object go undeviated through the center of the lens. If they go parallel to the axis, then they go through the focus, so that here they're diverging as they leave the lens and seem to come from a point right over here. That point which they appear to come from is the virtual image of this object. And notice that it is the distance from the axis is larger than this. This represents a magnification. In this experiment, we'll measure the magnification, and we'll also locate this virtual image by the method of parallax. That we'll do as I'll show you in a moment. Here is the lens. Let's look into the lens from the edge as I put it up there. You can see it's only a half a lens, so that we can look both through the lens and over the top of the lens. What we'll look at is this object here. It's a little scale. When I put the lens in front of that, it becomes magnified. In order to locate the virtual image, we will put behind that system another little ruler, which you can see I'm moving now over the top. If I look over the top of the lens, I see the ruler. If I look through the lens, I see the scale, which is magnified. But of course, I must first find that virtual image, and that we'll do by the method of parallax. Just to illustrate the method of parallax, I will show that here with this grid. Here I have a piece of paper with just a line on it. If I put this grid in front of it, then as I move the two back and forth, notice that the line moves with respect to the grid. Let me do that again. I'm just moving them both together and see how the line passes over the grid. However, now let me bring the paper right up to the grid. You see, now they're together, and I'll move them back and forth. And the line and the grid, of course, don't move with respect to each other. When I have them far apart, then I get this relative motion. I will do the same thing looking into the edge here. Let's look into the here for a minute, and I'll look through there, and then I'll move my head back and forth like this. This is analogous to what we were just doing. Let me straighten this out just a little. Get everything parallel. And now let's look in there and move back and forth and see how the magnified image, which is the lower one, moves with respect to the ruler, which is the upper one, as I move my head back and forth. That means, let's look down on the top of this for a minute. That means that the virtual image, it may be here, whereas the ruler that I have and I'm looking at is in a different position, so that as I move my head, I get a relative motion between this ruler and here. The only way I can fix that is by moving this and looking in it again. So let me look through here for a minute, and I will try and adjust this now so that I see no parallax as I move my head back and forth. I still see some parallax. Let me make a little better adjustment here. I'm going to do that. Now I have very little parallax. Let's look at that through the end. Let me straighten these out just a little. See, they're not quite straight, so it's a little hard to see them. And I'll straighten the lens too. And now move back and forth. And there's still a little relative motion. Of course, they both move, but I'm only interested in the relative motion, and there's a little. Let me adjust it a little better. I move my head. That's just about perfect. Let's look in the end again and move back and forth. Notice that if I follow any one line on the magnified image and compare it with the line on the upper one, the two move right together. That means that now let's look down on the top. That means that the virtual image is right here, and that this ruler is right here, and so now I have located the virtual image. The distance from the object, which is this, over to the lens I can measure on this scale here. I can measure the distance from the image to the lens, and I can check the lens formula. Of course, this should be straight, probably, to make it a little better. Now let's look through the system once more. Notice that I have large divisions here, and I have small divisions here. I can do some counting. I can count in 5 small divisions here. I can count how many large divisions? Just about 2. So that the magnification then corresponds to 2 large divisions, which are actually magnifications of a millimeter. And here I have 5 millimeters, so the magnification will be a factor 2.5. The next thing to do will be to pick another position of the virtual image, of the object, and then relocate the virtual image. Again, I will be able to measure the distances, and I will again be able to measure the magnification. This is what the experiment is doing, and what I won't do any more setups now, but that was just to demonstrate what will happen. One can move this steadily further away. Now let's look through the end again and see what I see, which is nothing. I see this little ruler back here, the white ruler, but I can't see any image of this. That's because I have now moved my object beyond the focal length. So let's look down on the top, and then we'll look through it again. Now this distance is greater than the focal length of this lens. I'll move it in slowly and watch what happens as I look through it. No image. Now I must be just very close to the focal point, and now I'm inside the focal point and I see the virtual image with, as you see, a rather large magnification. Magnification which I can't determine because this probably isn't in the right place, but once I get it in the right place I can remeasure the magnification.